For an ideal gas, the product of the pressure and the volume is a constant for a constant temperature. If you change the temperature, the value of the constant changes, but the product of pressure and volume is still a constant. Let's look at how changing the temperature affects our curves. Here we have our curve on the pressure versus volume plot. If we go to a higher temperature, that shifts the entire curve. On our linear plot of pressure versus 1 over volume, the slope of the line changes for a different temperature. So pressure times volume is a constant reflected on two different plots. Now, the product of pressure and volume being a constant means pressure and volume are inversely proportional. As I increase pressure, volume decreases. Decrease pressure, volume increases. So their product is always a constant. It turns out that's how your lungs work. In order for your lungs to draw air in, your chest cavity expands, higher volume. That means lower pressure. And high pressure air from the atmosphere can rush into your lungs. As your chest cavity contracts and goes to smaller volume, then you'll have air expelled out because smaller volume, higher pressure, high pressure air inside your lungs, expelled out into the atmosphere. We can look at that happening on a model. Here's a model chest cavity. The model chest cavity has that muscle in your chest, the diaphragm. And when that contracts, the volume of your chest cavity increases. Higher volume, lower pressure, air rushes in. And your lungs expand. Now, as that muscle relaxes, the volume of your chest cavity decreases. And what you find is air rushing out. Decreased volume, higher pressure, air rushes out. We can listen to it happening. So we can hear a model chest cavity breathing, taking advantage of the relationship P times V is a constant.